When adding and subtracting algebraic fractions, once again we remember our rules for adding and subtracting just the normal fractions with numbers in. What the main concept is that we make the denominators the same, and we make them into what's called the lowest common multiple, LCM, in this case of 4 and 3. Now if we write out the factors of 4 is equal to, in prime factors, is 2 times 2, and 3 is just equal to the number 3. Now to get the LCM of 2, we actually write out 1 completely and then say, are there any 2's there? No. Are there any 3's included here? No, so we've got to add a 3. So the LCM of 4 and 3 is 2 times 2 times 3, which is equal to 12. So we're going to make both of these into twelfths. So to make the first one, we write it as it is, a on 4. To make this into 12, we multiply by 3, and to make this into, whatever we do to the bottom, we've got to do to the top. So we multiply by 3 on the bottom, multiply by 3 on the top, plus, write this as it is, and we want to make this into 12 by multiplying by 4. We do that at the bottom, we do that to the top as well. So now we've got 3a over 12 plus 8a over 12. Now that we've got the denominators the same, we can just write it as a single fraction, and we simply add, or if this was a subtract, we subtract the top. So in this case we've got to add, we've got 3a plus 8a, which is 11a over 12. Now that, incidentally, that's the answer, but if you want to, you could say that that is 11 over 12 of a, 11 twelfths of a, almost a complete lot of a's. Alright, so similar type of method that we use for just ordinary fractions, except when we've got these variables, in this case a, we still apply the same concepts. Let's look at this again. We want to make the denominators the same. So we've got 3x is equal to 3 times x, and 6 is equal to prime factors 2 times 3. So the LCM, the lowest common multiple of 3x and 6, is equal to, we just write down, just choose one of the factors, doesn't matter, 3 times x. Then we look at the second factor and we say, have we got a 2 down here yet? No, we haven't, so we've got to put a 2 down. Have we got a 3 down here yet? Yes, we have, so we don't have to put another 3 down. So you just write out one set of factors as per whichever one. Then go to the second lot and say, look at here, have we got 2? No, add the 2. We'll multiply by another 2. Have we got a 3? Yes, we have, so we don't. So 6x is the LCM. So we're going to make both of these denominators into 6x. So we write out 2x plus 1. Probably a good idea to put this in brackets because we're going to be multiplying by something here. And we've got 3x. Now we want to make it into 6x, this. So all we've got to do is multiply by 2. If we do that to the bottom, we've got to do that to the top. Plus, we've got x squared over 6. We want to make it into 6x, so we've got to multiply both top and bottom by x. And that will be 2, bring the 2 at the front, 2x plus 1, all over 6x, plus x times x squared is x cubed, all over 6x. Now that we've got the denominators the same, we can just combine them into one fraction. Might be a good idea to just remove this bracket and we get 4x plus 2 plus, and then the x cubed. Once again, probably go in descending powers of x, so x cubed plus 4x plus 2 all over 6x. Okay, so we've added those two algebraic fractions. Subtraction, similar type of thing. We look here and we've got n squared minus 1 and we've got n plus 1. Now we've got to work out what the LCM of those two are. N squared minus 1 can be factorising using the difference of two squares. A squared minus b squared is a plus ba minus b, so this will be n minus 1 times n plus 1. You multiply that out and you'll get n squared minus 1. And over here, the second denominator is n plus 1 and it's just n plus 1. So the LCM of n squared minus 1, oops, we don't need a bracket there, we'll put the bracket at the end. N squared minus 1 and n plus 1. Write out one complete set of factors. And you say, okay, that's one complete set of factors. Look at the next one. Have we already got an n plus 1 in here? Yes, we have, so we don't have to write another one. And that's it. So that is the LCM of those two. So we're going to make both of these into n minus 1, n plus 1. Okay, so that's what we're going to make them both into. This one is already there, so we don't have to multiply it by anything at all. N squared minus 1, sorry, n minus 1 times n plus 1 is n squared minus 1. And that is the denominator, so we don't have to multiply top and bottom by anything. 3n over n plus 1. What have we got to multiply that by to get n minus 1, n plus 1? Simply n minus 1. And if we multiply the bottom by n minus 1, we're going to multiply the top by n minus 1. Bear in mind that all of that is still 3n over n plus 1. What it has done though, n plus 1, n minus 1 is the same as n minus 1, n plus 1. We've got the same denominators. So n minus 1, n plus 1 is the same denominator. So now we can combine the tops. So we've got 8 minus, and we could actually multiply out. Now the 3n times n would be 3n squared. Now that's minus 3n times minus 1 will be plus 3n. Probably a good idea to get these in ascending order, because that'll make a positive 8 as the leader. So 8 plus 3n minus 3n squared. And we can put this all back together as n squared minus 1. So adding those two fractions gives us that as an answer. Sometimes it's helpful to work backwards when we want to split this into its individual fractions, and it's a matter of going backwards with addition. So if we've got it over a single denominator, we can put each of the terms on the top over that single denominator. So this would be a over 7 plus 1 over 7. Now you know from what we've just done, to add those two together, because they're both 7ths, we just write the 7 down and then we just put a plus 1 on the top. But sometimes just splitting a single fraction into its individual parts will be helpful in some of the maths we do in the future. What about this one here? We've got 3y over y minus 8 over y. Can we cancel that y with that y? Yes, we can, because that y is connected to 3 by multiplication. You can connect things, you can cancel when it's got a multiplication. So y to y once, y to y once. So we're just left now with 3 over 1, which is 3, minus 8 over y. Okay, so that's working backwards, something that you should be familiar with, that you may need in the future. But when we are adding and subtracting fractions, as we've done in these 3 examples up here, make the denominators the same, make them into the LCM of the two denominators, and then we add or subtract the tops and simplify if necessary.